Hello, good morning, good evening. So today we're going to be talking about input shaper on the Voron Switchwire. Some of this will also apply to Enderwire. I haven't made an Enderwire myself, but I have made the Switchwire, and I've noticed some things. There's slight mechanical differences between the two, Enderwire and Switchwire. So I think most of this will apply. It might be slightly different. You might get slightly different results, but for I'm going to direct it to the switch wire, and then as I see more Enderwire stuff, I can adjust this video and discuss that. So what we have here is your standard, your bomb switch wire, and this is called a Core XZ. So we have, and the reason for that is this is your y-axis. Let me get my pen, make it in red. Your y-axis comes out like this. Your y, your x-axis is here, and your z-axis is here. And the thing is basically a Core XY flipped 90 degrees. So this is now this would be the same as your Core XY. And this does some slightly different things because it's a Core XZ and because the two motors, your A and B motors here, now control the Z. We can't do belt shaper on this at all. Clipper does not support a Z belt shaper. There's no Z axis to map to. You get X and Y, and that's it. So what does this mean for input shaper or for belt shaper? Belt shaper, we can't use it. For input shaper, it means it's a little bit more difficult to tension our belts. We are more at the mercy of our tension app or the tension tool. There's no real fine tuning per se on belt tension at all. You get whatever you get on your tension meter or your app is what you get. So, especially for y-axis. So what I have found though after building this thing is that we need to talk about some mods to begin with for this switch wire. I know there's discussions of potential updating the switch wire as it's one of the oldest, I think besides Legacy, oldest design of Vorons that hasn't been updated. Um, but there's a couple mods that we need to do first to really get this thing, make it easier in effect to work with. So the first mod we need to talk about is let's get rid of all that, is Yendas. So if you go to Voron mods, you pull up Yenda, more robust. Right here, we'll go to its GitHub. This is what we need right here. This aspect right here is what we need. Because what you'll find is if you start building this thing here, I got some more pictures to show you. Let's see here. Just subplant this guy in here. So this is the Yenda mod. This is also Yenda mods here. It's adds an extra screw on top here to really be able to line this stuff up on the extrusions. This is not as critical. Um, this X1 right here, this is not as critical as this is. So what does Yenda do? Let's get a better color here. Yenda gives us this little notch here where we can attach a screw into, an M5 screw. And why is that important? It's important because to tension these, both the X and Z motors, which are the AB motors, which are right here, you have to unscrew this here, unscrew another M5 here, and then you use this screw to move this up and down. Well, when you unscrew these guys, unscrew these two screws, let's call this 1 and 2, this motor is going to separate off the build plate or off the Z extrusion. So then when it does that, you can't get a good tension on this because you're going to have your hand against this, pushing this way, preventing rotation on left and right. Whereas if you have this mod here, you can screw it in the extrusion. it makes tensioning so much easier because this motor now is not going to come out off the extrusion. It's going to go a little bit left and right, but you don't loosen this screw up here so much. You just loosen it enough that you can gently move this thing up and down, because really we want this, let me get a bigger brush here. We want this motor to go up and we want it to go down. We don't want the horizontal movement. So this is the first mod we need to do. And if we go back to Yenda here, pull up Yenda again. So Yenda has this. This is the additional mod. I did this one just to test it out, and it works pretty good. It lines it up, as I said before, on the extrusions. I didn't do this one. I didn't need to see, it adds this extra thing here to really secure it. But the Yenda mod also adds a screw so that this doesn't separate. This whole mod, I would say if you're going to start trying to really dial in your input shapers on Switchwire, this mod is a must for your X and Z. Without it, you're it's going to be more difficult to make adjustments because that motor, as I said, is just going to want to separate and come off of the extrusion. So the next mod we need to talk about, and that's going to be the 9mm for Switchwire. And if we scroll through here, got to find the right one. So there's a whole bunch here. I tried this one here, the tensioner. It applies too much tension. It doesn't. You would think it would work well, but it's not working as well as I had hoped. But so I took that off. I found that just using my fingers, the tension on the Y was enough. But where is it at? This one right here. So I did this mod, but I did it with 6mm belts, and I didn't do the panels. So I have a picture of what that looks like. It's not pretty, but it does its job, and I'm not getting any issues. So this is the same. Let's see if we can put them side by side. So right here you can see that this is a special panel with the cutouts. I didn't do the cutouts, so mine is right here. It's basically resting on top of the plastic. This whole thing is resting on top of the plastic, the deck panel, and it's just kind of pushing it. I didn't have an issue with that. These are the tops half of a sex bolts I used because I didn't have the right M5 screw, so I just used half of a sex bolt. But this is good. It comes with the motor too. So we'll look at I believe I have pictures of the motor also. This is good because what it does is it takes your Y belt outside from underneath the extrusion. What I was finding was that any sort of imbalance, so you have, let's just imagine this is your extrusion, and over here is your motor pulley, right? And then over here is your bearing. Well, if this guy was high, and this guy was, your belts would start doing something like this, or they can go the opposite direction, right? And what you're going to find is it's going to start hitting a little bit of that extrusion on one side or the other, because these extrusions aren't, they're not perfectly engineered pieces of metal, right? They're just literally extruded aluminum. So, and we're running it inside the channel. I wasn't getting much luck. I was getting a lot of variations in my Y. So when I did this, and these are 6mm belts, as I said, on this side, I used the bearings and bearing stack here. And then on the other side, let me pull that up. So what I used here was G Gates smooth idlers. And you can see there's a lot of room here, but that's okay. This is my self-alignment. This is basically the same thing that we have going on the XY joints for a Core XY. So then the VT and VX, VT and V2. So these guys right here, they're nothing's on the bottom here, nothing's on the top here. It's just this, and they can freely float up and down. And then this is going to be your tension, right? You loosen this screw, you pull it back, you tension it. This is working really well for me. It's taking and you can see I can't quite get it so it's not hitting a flange, but you'll see later it's not really a big deal. On this design at least. I would like it not to, and I would like it that if this were little nipples here to separate it, but it's not, and I'm working with it and it's doing well. So you don't need to use 9mm belts. You can use a 6mm and it works fine. You just need you can't do bearings back here. You have to do smooth idlers if you're going to do the 6mm belts, and that's because the bearing, right? You got a bearing stack like this, right? We'll call that a bearing. We'll call this a bearing here, right? But there's a space there, and if you put a 6mm and you've got like lots of room up here and lots of room up here, if you put a 6mm belt on this bearing's going to go up, this bearing's going to go up, and now you're going to be riding in the middle, and it's no good. So if you're going to do this with 6mm belts, do it with buy the smooth idlers. So that's what I did, and I found that these two mods, the Yenda's mod and the 9mm mod, worked out really, really well. Let's see if we can go back to my original pictures here. Probably not. That's okay. So those worked out really well. What's the other thing you need? You need to have, let me pull that picture back up because that's got exactly what I want. So this right here, you need a second ADXL or second accelerometer. So generally we'll have one on the tool head, right? We'll have one, it'd either be part of a CAN bus, you might be using the new LDO Nighthawk, it might be another LDO one that goes like on the side of the stealth burner. It's got those two, like where you can see it right there. It goes on the side, something like that. That's one for the tool head. You need a second one for the machine, for the bed itself. And you can run both at the same times with some limitations that we'll talk about. So the best place, and now Steve from Steve Builds and I had a big long discussion about this. I've had a discussion with Pfmakes about what is the best placement for this bed, for this accelerometer or ADXL right here. Is it in the center of the bed, or is it someplace where you're going to get the full weight of the bed plate on it and on the side, right? So if you look at Steve Builds, he took it and he made an ADXL holder, and he put his right here. So I'm using the silicone mod, and that's just so I can level my bed. But if you're using like the metal spacers like Steve did, you can attach it right there. And what we've found though is that when you attach it, this bed is not stiff as a bed, like a regular Voron bed, right? It's not solid metal, right? This is a flimsy PVC, it's relatively flimsy PCB board on a relatively flimsy aluminum frame here. So where's the best place to measure this thing at? For a while, I was measuring in the center because the center you're going to get, let me back up here. Clipper can only cancel one frequency. It doesn't do a very good job of canceling multiple frequencies. It does better than I thought though, but its best is one frequency. If you mount it on the center, this Provost or Boxy 8XL, you can mount it on the very center screw, pull that out, mount it there, but you won't have a build plate on it, and you'll get a very clean center peak. It's somewhat devious though, because that only really works if you're printing in the middle of the bed. If you're like me and you like to use the full entire bed when you're printing, you don't want to always print one little thing. You maybe have 15 models on this thing, or printing 6 flimsy flexible dolphins. You're going to want to put it here because this is going to give you a more accurate representation of what the entire bed is seeing, especially your models out here, out on the perimeters. If you only print in the very middle, maybe a square like that just in the middle, yeah, you can put this right here, uh, but it's not necessarily accurate. I'm going to explain why later. So those are the mods you got to do, and that's the ADXL. So this is the ADXL I use. I use this one, and why do I use it? I use it because it's tiny. First off, it's Provost. It's 1899. It's got an actual ADXL 345 in it, not an LIS 2DW. The screw holes are great. That's a 5mm screw hole. You can mount it on an M3 by using exactly what I did here. Let me pull it back up. I've got an M3, M5 washer, followed by an M3 washer, followed by an M3 screw with the M3 screw below. So just like this, I can put this thing anywhere. It is tiny. It doesn't get in the way of things. It's not hard to mount. I know there's plenty of these other ones, but this is what I use, and it has not let me down yet. And no, I don't get any money back from this. I just really like it. Same way I really like the Pfmakes tension tool. That thing is just great. That's the mods, and that's why we're doing it. So let's get into the graphs then. So we talked about that. Let me get some graphs here. Okay. This is what you're gonna. If you put your ADXL on the tool head, and you put the ADXL on the back of the bed, this is what you're gonna get. This right here is your bed. That is your bed wobble. Your bed is gonna wobble, vibrate up and down. You can see there's lots of Z in it, which is, in this case, it's Y, so the red is Z. There's lots of Z right here. You're getting some Y. So it's not such a big deal. After reading Clipper's documentations multiple times, for Switchwire and Enderwire, for bedslingers in general, Clipper recommends, let's blow this up, can we get this bigger? Clipper recommends to use EI. Okay? Not everything else, we want MZV, right? For all the Core XYs, we want MZV. But for bedslingers, because of this, now you might be able to get MZV on your X-axis, which is fine. But for Y-axis, you want EI, which means your Y-axis is really going to, depending on the tension you apply to your Y-axis, it could be your limiting factor. I think that the X-axis should be, but I'm still trying to tune this stuff in. So consider these preliminary numbers or preliminary graphs, but I'm getting no resonance on my prints. So that's the most important thing for me. I don't really care it's a bedslinger, so I'm not expecting to go, Core XY speeds, but I want some quality, so I'm getting that right now. So you're going to see this here. This is our standard. This is what we would expect, but you're going to get this because of the bed. It's okay. As long as you end up with, let me get rid of 0 vibrations, it's okay. Yes, we're going to get more smoothing than we did on a Core XY. A Core XY will get us probably 0.6, so 0.06. All right, we're at 30. Our acceleration is down. Now, our acceleration can be controlled by how much tension we apply on that Y belt. So this effectively is our belt shaper for Y. It's our input shaper and our belt shaper because it's only one axis. So we can get rid of some of this. We can increase speed by tightening that belt. But what I've noticed happens is that this peak starts riding up. And you're going to start seeing you potentially could start seeing some trash over here. I believe this peak will come this way. This peak generally stays around here, so you may end up with something like, let me get rid of that, that's ugly. Something like this, where they get closer and closer. Your vibrations are going to go up. This number is going to go up. so it's a trade-off, right? How fast do you want it to go versus can you do EI? When you start getting into two hump and EI and this stuff here, this is just gonna be garbage. You don't want it. So this right here is directly tied to our Y tension. This is our belt shaper for Y. And if you put the ADXL in the middle of the bed, you're only going to get this peak, which means everything else around the perimeter is going to be seeing this. So once again, if you print in the middle, only in the middle, you go ahead and set your ADXL there. All these values here these will all be a lot better. But if you print full beds on your Switchwire or your ender wire, you're better off just putting your ADXL on the side here and going that route. For x-axis, what do we see? Well, I had this is kind of junk, right? This is junk. It's not the greatest. I'm getting vibrations here, but this all has to do with the tension on the motors. You effectively have to de-rack and retension at the same time on these things. It's very difficult because they're in Z and the axis and gravity is a thing and it wants to pull on your x-axis. It's very hard to separate the de-racking process from the tension process. So you get what's here. What I have found is, at least on my machine, I am always going to get something like this. This right here can be reduced. I can set it up and redo it and recalibrate it and change the belts, and this will get reduced. So that's, to me, is not a worry. And this right here, I can get slight improvements on. But I'm always going to have, whether it's a small thing here or if it's a smaller thing here, I'm always going to have these. I can't get it to MZV, but I will still use EI on this. You know, my smoothing, I mean, Y is going to have a smoothing of 0.3. My smoothing on EI is it's going to be around 0.2, and if I slow it down, it'll be about 0.3. You can tell that my tension on my Y, I can increase it because it should actually be better accels on Y than there is on X. Just because there's less mass, I believe, on the there might be. I haven't actually measured it. I'm thinking there's less mass on the y-axis than there is on the whole XZ axis. But so I got some room. I got some fixing that I can do to improve it. But this is the general shape of what I've been seeing constantly. Let me go pull up another one where I've done this. So this is the test I did. You can see this is what I was able to get, and I'll explain what this. I measured the tool head here with the tool head ADXL, and I set it to run on both the bed and the tool head. So the tool head is picking up the Y motion from the bed, and then I have a bed ADXL that's picking up the Y motion from the bed, but it's also picking up the tool head. I wanted to know what effect the bed will have on the tool head and what effect the tool head will have on the bed. And what we can see is it's really low. It's like 1 e to the 2. So if you look at this, this is 1 e to the 2. Well, this is 1 e to the 4, right? This is half. So this is 5 e to the 3 right here. Right? So that's 5 e to the 3. Right? And this is 1 e to the 4. Well, we're 1 e to the 2. So where is that at? Right? That's going to be way down. That's like here. So this, even though it's a nice, pretty spike, it's noise. So these don't matter. Boom. Just knock them out. They don't matter. So what it's just telling me is that the amount of noise generated on the bed does not really influence the tool head too much. And the tool head doesn't really influence the bed as far as input shaper and accelerations go. So what else are these graphs showing us? Let's pull this. Let's go blow it up here. We can see that this is a fairly good graph here of the y-axis. You can see I have a little bit here, which was way before it was up here, and I still have this here, which up here was like this. So there is room for improvement. On my previous graphs, I was able to get, um, pretty good accels, 0% vibration. I just got to a point where I had to stop. Uh, as many of you know who've done input shaper a lot, at some point you just have to stop. It'll drive you nuts, and even though we're all trying to get the best possible, sometimes you just let it go. I have let it go. I'll probably go and fix it when I start messing around again, but right now it's still printing great. It's not as fast. I'm not printing super fast, but it's doing its job. This is why. Now this was measured, once again, you can see this hump. It's going to be there. I think this one was actually measured in the middle of the bed. So this is in the middle. So even in the middle, you're going to get that hump. But you can still get MZV at 0. So that's basically what we're seeing. So what else do I got for you? So the next thing is the vibrations. So I got this is probably one of my better graphs. I just replaced the motors. I took the stock motors, replaced them with different ones. I forget the name of them right now. We'll look that up. But this is what we see, and not great on the core on the core XZ. And I'm thinking this has to do with my belt tension more so than the motors, or it could just be the general way the motion is. You're getting some noise here. The peak here is good, but I think there's some more working I have to do. Maybe change the currents on the motor, give it something else. This is pretty noisy, my spectrogram. I am printing at around 125, and it seems to be doing okay on perimeters. So yeah, I got to figure out what's going on. But this is you're going to find that your x-axis is going to be dirty. You got two motors going at the same time, and it's got to just be the orientation, I'm figuring, or the setup. This is what it's going to look like. Your Y motors are definitely going to look a lot better. So your Y motors here, single peaks, a little bit there, but definitely cleaner. If we put them together to figure out our print speeds, this is basically how I figure it out. We take a box here. We say, take this orange line to this orange line. There's a print speed. Take this green line to that. We can probably go push it a little bit more. There's that. And then this is the limiting factor here, so we'll take this line to here. And then of course, we'll go to our slow speeds here. So it's not as bad as one would think. I mean, you've got high speed over here at about 130, maybe 140 right here. So you got your high speed where it seems to be doing at 140. You got your low speed. You could do it anywhere here. So that's what, 90 to 100. You got 50, which is good for tops and stuff, tops infill and stuff. And then you have potentially gap fill down here, right? So it's not as closed off as it initially looks from your x-axis, but you definitely, this peak right here, I gotta find the cause of that because that's really slowing down. I'd have a lot wider range of speeds. So that's so far that's what input shaper is on the Switchwire. Not as easy to diagnose as Core XY. You got a lot more junk going on in it. A lot of a lot more issues. I mean, this right here, x-axis, this is all about tension, it's all about tension. So once you sort that out, uh, these graphs go away a bit. Um, so that's kind of what I'm thinking. So that's what I've discovered about this input shaper in on the Switchwire. Not too much troubleshooting yet, or third-party troubleshooting. This is more of my own discoveries of what I've had to deal with. I will say that there is a PDF going around of some graphs I've done for Core XY. That is not to be used on bedslinger. It's just not valid on a bedslinger because of the different kinematics. The issues that it shows are not, they're just not going to be the same. And really, gravity and the whole setup of how it's set up, you you can't say that this is, on a y-axis. I'd say that this would be your CAN bus or your umbilical or tap potentially, right? You can't say that on this. This is, I personally think that's the bed, the PCB bed, and potentially it's definitely part of the linear rail. You want a Z2 linear rail for your Y, or Z1. You want a Z1 linear rail for your Y. But it could be the flimsy, the it's not as robust and it's a wider thing. So this is my 2 cents. Let me know what you guys think. If you've got something else, definitely hit me up in Voron Discord. We can talk about it. If you found a different graph and you said this is my problem, I'll definitely took a look at it. For me, this is relatively new in the bed slinger department. So I'm still learning. I'm playing with mine, trying to figure things out. I don't want to turn it into a breaking machine like my 350 Trident. So I'm not as open to testing new things out on it because I do need it to print. But yeah, if you've got issues, just hit me up and maybe we can work them out together. All right, thanks, and have a good night, good day.